We're into the second lesson of the week, and we're going to look at energy efficiency. We're going to learn to calculate energy efficiency. Right. So we're going to talk about bulbs. Okay. Now, when you talk about light bulbs, there's really three kind of light bulbs that are being used. One, which actually we not really been using for quite a while, is filament lamp. Okay. Now, filament lamp, just one L. Were very popular until not too long ago. They're basically these bulbs where there's a little wire. I'll just do it here. I'll do it here. There's a little wire, and then like it coils like this, and inside this. So inside these bulbs, still sometimes small little bulbs, you can see that little curly thing there. And basically, it's a metal called tungsten. Okay? The electrons flying through it, and from the friction they make it a little bit hot and glows, and that's the light comes out. Okay. Now, all kind of bulbs. Okay, I'll mention the other ones in a minute. They take electric potential energy, as we saw in last lesson. They convert to some of it to light and some of heat. Okay. Now, what we're going to do is calculate the efficiency of each one of them. So let's give you some number. Let's say we are working with 100 joules. 100 joules of electric potential energy. Now, numbers I'm giving you are typical numbers. I got them from the web. If you took 100 joules of electric potential energy, okay, you would get something like 15 joules of light, and therefore 85 joules of energy. Okay? Obviously, the amount of energy of light and heat must add up to the amount of energy in the electric potential energy, because conservation of energy. Okay? Now, if I ask you, what's the efficiency? What's the efficiency in this bulb? Okay? Right, without even saying what efficiency means. Okay? I think some of you will correctly say, sir, 15%. How do you know that? What you do, you'll take the amount of energy of light, which is 15, divide by the total amount of energy you got into the bulb, okay, which is 100. And because it's percent, we always time by 100, and we get 15%. Okay? What is energy efficiency? Is the amount of, or the amount of energy, or useful energy output. Output was the light that comes out. It's the output energy, the useful output energy, not the heat. Heat is not useful. Okay? It's the output energy divided by the total input energy, okay, which is the amount of electric potential energy, time 100. So let's make a note of that. Okay, so I've magicked it now. Please copy that down. Just pause me and copy that down. The efficiency is defined as the useful energy. Sorry, I made a mistake. It's the useful energy output, okay, divided by the total energy input. What do I mean output? Output is the energy that came out, but I'm not counting all the energy that came out. I'm not counting the heat. I'm just counting the useful energy. So that's, in this case, 15. Divided by the total energy that going in. That's the input. Okay, once you copy that, let's have a look at the halogen. So, halogen, okay, again, if I give you some kind of numbers, so let's say if I take 5 joules of electric potential energy, okay, the amount of light you're going to get seems to be something like 4 joules. Okay, these are numbers that I took again from the web. Rough, okay, obviously there's different halogen. Ooh, what is a halogen bulb, okay? So in the classroom, at least in my classroom, okay, bulbs are these long tubes, these long white tubes, about 1.5 meters tube. These called halogens. Halogen is a gas, okay? You've learned about halogen gases, okay? There's a gas inside that tube, and once we create a potential difference between both sides, that gas actually conduct electricity. There's a current of electricity and lights up, okay? So if 5 joules of electric potential energy becomes 4 joules of light energy, how much heat was created? You're right, about 1 joule of heat. And what would be the efficiency now? Okay? So we're going to ask ourselves, what is the useful output energy? Again, in this case, it's the light, so it's going to be 4. Divided by the total input, in this case, it's 5, time 100. Okay? And what you'll get is 80%. Okay? And these are the numbers that I got from the web. 80, sometimes 85%. They're much more efficient. That means they're not wasting so much energy. That's why we're not really using these tungsten filament bulbs anymore. Also because we don't have much tungsten anymore. But they're much more efficient. They might not be very pretty. I personally don't like these halogen, but they're much more efficient. Right, moving on to the more modern lights, and I'm sure you've heard of them. They're called LEDs. LEDs. Basically, in any kind of, in your phones, and if you have a torch, any torch that you have nowadays, okay, in your clock, everything is LEDs. And I'm not going to get into what this light emission diode is. Okay, you're going to learn it probably in grade 11 or 12, but I can just tell you it's very efficient. Okay, so let's say that I'm giving it 10 joules of energy, of electric potential energy. What you'll find out that the amount of light energy you have is something around 9.9 joules. 9.9 joules of energy, almost all of it. And that means how much heat are we going to have? Correct, 0.1 joules. What will be the efficiency of the LEDs? Okay. It's going to be the useful output, 9.9, divided by total input, 10, time 100, and we gain 99%. Okay? And LED's efficiency is around 90-something%, 99, 95%, okay? Obviously, there are different kind of LEDs, but they are really, really efficient, and that's why we use them, okay? So, I'm going to give you a couple more examples of a bit more difficult ones of problems that we could come across in a test about efficiency. Okay, so let's start with this example. Going back to a kettle, we spoke about a kettle, okay? So let's say we're heating up water with a kettle. And the electric potential energy that we're giving the kettle is 5 joules. Let's say we got 2 joules of sound. We can hear it, okay? What about heat? How much heat was generated, okay? Use the principle of conservation of energy. Let me just pause here, there's a bit of sound. Okay, so yes, so how much heat was generated? Okay, 5 joules of electric potential energy, 2 became sound. Obviously, heat was 3 joules. Okay, principle of conservation of energy. Again, what is the efficiency? Let's calculate the efficiency. You're going to be a bit careful here. Okay, efficiency is the useful output divided by total input. Now, what is the useful output? Okay, what are we using kettle for? Are we using kettle to make a sound? No, we're using it to heat. So normally the heat was a waste product. We call it wasted energy. But in this case, the heat is what we're after. So the useful output is actually the 3 joules. Divided by the total input 5, time 100, we're getting 60%. Okay? So don't get confused, don't get used to the fact that heat is always wasted energy. No, heat could be the useful energy in heaters, in kettles, and stuff like that. Okay? We're going to do one more question. Okay, so the last question is a bit more difficult, and you can find these things. Okay? Phone charger. Okay, a phone charger converts electric potential energy to chemical potential energy in your battery. Think when you connect your phone to the phone charger and you're charging your battery, okay, you're obviously taking electric potential energy. What kind of energy a battery has? We spoke about it. A battery, okay, is there's some kind of chemicals there. So using a chemical reaction, we're converting, or not, yeah, chemical reaction, convert the electric potential energy into some kind of chemical energy in the battery. Okay? And then that chemical potential energy in the battery, once it's full, then we can use it to convert it to light energy, sound energy, whatever we want to do with that phone. Okay? But whenever you have a battery, you basically have chemical potential energy. Anyway, it has an efficiency of 70%. So it converts 70% of the electric potential energy into chemical potential energy. Now, this could be quite a difficult question, okay? The first question, I didn't write it down. I can ask you, what's the other kind of energy that it produces, the phone charger? So if we take electric potential energy, and convert some of it to chemical potential energy, what's the other kind of energy that it releases? If it's not 100% efficient, there must be some kind of energy. Okay? You ever touch your phone charger or your phone when you're charging it? Okay? Becomes hot, right? So we're getting some heat there. Okay? Now the question that I'm asked here really is how much energy, chemical potential energy there is if I use 3 joules of electric potential energy. Okay? So I know the efficiency. Here I have to calculate the efficiency. Now I know the efficiency and I want to calculate how much useful energy came out of it. Okay? So how do I write it? What I would suggest is just remember this equation, and I will put that for you in a test, and just substitute it. Okay? You know that the efficiency is 70%. Okay? 70%. So you write down 70%, okay, is equal to, right, the useful energy, which I don't know. What is the useful energy? Is the chemical potential energy. I don't know how much it is. Okay? So I'm just going to write chemical potential energy. Divide by the total input energy. Okay, what's the total input energy? Is 3. Okay, 3. Okay, so 70% equal chemical potential energy divided by 3, and I must multiply it by 100. Okay, as the equation suggests. Now I want to find out the chemical potential energy, how much it is. So what I got to do is time, or you have to rearrange it. Okay, so I'm going to write chemical potential energy. Okay, you've done stuff like that. First of all, we're going to divide 70 by 100. Okay, so we'll write chemical potential energy divided by 3 is 70 divided by 100. Okay, I move the 100 to the other side. Okay, running out of space, so I'm just going to write it down here. Don't mind. Okay, and now I want to get rid of the 3, so I'll time it by 3. So the chemical potential energy will be 70 divided by 100 times 3. You could have said that from the beginning. You could have said, all right, if I have 3 joules of electric potential energy and the energy efficiency is 70%, so it's only 70% out of 3 will be chemical potential energy. You could have done it straight away. Okay? And for that, obviously, we need a calculator. So I'm going to write 70 times 100, or 0.7, you can do it straight away, times 3, okay? And I get 2.1. So 2.1 or 2.1, and we got to give the answer in joules. Okay, that's the unit of energy, joules. Okay, J stands for joules. We have to write down units, guys. In physics, we must write units. If you miss the unit, you lose a mark. Now, another question I can ask you here is, how much heat was generated? Okay, how much wasted energy was generated? Now, you know that 3 joules of electric potential energy was given to the phone charger. Only 2.1 actually became the useful chemical potential energy. So the wasted heat energy, okay, will be 3 minus 2.1 joule, which is 0.9 joules. That will be the answer. Okay, so that's the level of the more tricky questions. Still not too difficult. See you in the next lesson. Ooh, just watch the video below. It's quite a fun video. I think you'll enjoy it. Okay, it's about the principle of conservation of energy.